This lesson is on finding the percent of change and the percent of error. So percent of change indicates how much a quantity increases or decreases with respect to the original amount. So we are going to set up our proportions. So since we're trying to find out a percent, percents are always out of 100. So if we're trying to find the percent of change, then to be proportional, the number that goes here should be the amount of change. And it's always respect to the original, so the denominator is going to be the original. So I remember this as CH for change and OR for original. I remember it as chore when I set up my proportion. So if we look at example 1 from our notes, it says, Miss Mizuko picked Drew Brees as her quarterback in fantasy football for 2 weeks in a row. Find Drew's percent of increase in fantasy football points. So if we look here, Drew Brees in week 9 scored 15 points. Then in week 10 scored 21 points. So this is a percent of increase because the amount of points went up. So if we set up our proportion, we want to know what that percent of increase was. So our x is going to go over our 100, and we want to find the percent of increase in points. So the number that will go here is the number of points that it was increased by. So 21 minus 15, that is a change in points of 6 points. And his original points were 15 before it changed to 21. And then we are going to simplify, so we could divide this by 3. And then to solve this proportion, like we have in the past couple of weeks, we can point to the x, go diagonal, and 5 times 20 is 100. So 2 times 20 is 40%. Or you can solve it also as 5x equals 200. Either way you solve it, you'll still get that the percent of increase in points was 40%. This makes sense if you think about it. Half of 15 is 7.5. So if we add 7.5 to that, it was almost a 50% increase. It's almost half of that added to it to get to 21. It's very close. But it was less. It was only 21, not 22.5. So it's close to 50%. Notice 6 and 15 are almost half. Half of 15 is almost 6. That's why it's less than half of 7.5. So the percentage is less. Okay, now if we take a look at one from your homework, go ahead and take a look at number 3. This is from your homework. It says, the staff at a company went from 28 to 7 employees. What is the percent? And notice it's a decrease. There was 28 people, now there's 7. So I'm going to set up my proportion. I want to find a percent. Percents are out of 100. And this x represents the percent of decrease in employees. So the number that will go here is how many employees was the decrease. So 28 minus 7 is 21. So there was 21 less employees now, and the denominator is the original. Originally there was 28 people, and the amount of employees decreased to 7, decreased by 21. So then we are going to simplify. point to the x, go diagonal, and 4 times what is 100? So then 3 times 25 is 75%. Okay, now if we look at number 1 from your homework, it says Carson bought his skateboard for $80. He saw the same skateboard at another store for $100. What is the percent discount? So he got a discount. That means he did not buy the $100 skateboard, he bought the $80 skateboard. So it says, what is the percent discount that Carson received? So for something to be a discount, that means the price started up higher and then went lower. So this is a percent of decrease. That means we saved money because it was a discount. So we want to know what the percent of discount is. So this represents the percent of discount. So the number that goes here should be how much was saved. So from 100 to 80, that's a total savings of $20. And then the original amount, for us to save $20, or for Carson to save $20, it was originally, the skateboard at one of the other stores was 100. And then we can see that if we point to the x, 100 times 1 is 100, so 20 times 1 is 20%. Okay, then the next topic, so that was finding the percent increase or decrease. The next thing we need to talk about is percent of error. So this time, instead of finding by what percent something went increase or decrease, this time we're going to find the amount of error as a percent. So if we want to find the percent of error, percents are out of 100, the number that goes right here should be the amount of error, and the denominator instead of the original, okay, it's what the exact value or the correct value is. So if we take a look at example 5 from your notes, it says, Caleb needs to purchase a countertop for his kitchen. Caleb measured the countertop as 5 feet. The actual measurement is 4.5 feet. So obviously he measured it wrong. He was off by half of a foot. What is Caleb's percent of error? Round to the nearest whole percent. So we want to know a percent of error. So the number that goes here should be what was the error. So 5 minus 4.5, that's how we got that it was off by a half. And then the denominator should be the exact value. The exact value of the countertop, the correct value for the countertop, is it's really 4.5 feet. So we made a half of a foot error, and that was the correct value of the countertop. So then we're going to solve this proportion. I would move the decimal over 1 to the right. That's like multiplying by 10. So then I have 1 over 9, dividing both of those by 5. Now, using some common sense or some estimation, we should see that 1 and 9 are far apart, so this should be a low number for x. Our percentage should be low. Or if we go to the x and go diagonal, 9 times about 11 is 100. So I'm estimating that x will be like 10, 11, 12%, something like that. So then I have 9x equals 100. Divide by 9. And in my head right now, I'm thinking, when you divide anything by 9, that's a repeating. So round to the nearest whole percent, it's about an 11% error in measuring.